Welcome to Touch Tamil. Today we are going to discuss about EIGRP routing lab. It's a basic EIGRP routing lab which we are going to discuss today. Let us consider the two locations, Chennai and Delhi. Chennai and Delhi is connecting via Mumbai and Hyderabad. We have two paths. Now all these four routers we are going to enable with EIGRP. This location have two VLANs and Delhi also have two VLANs. The VLAN 10 and VLAN 20. Here in Delhi, we have VLAN 30 and VLAN 40. VLAN 10 gateway will be 10.10.10.1. VLAN 20 gateway will be 20.20.20.1. We will be enabled here router on stick. The similar fashion we will be enabling here router on stick. For VLAN 30, gateway will be 30.30.30.1, and then VLAN 40 gateway will be 40.40.40.1. And we will be creating here two VLANs. In this switch two VLANs, here we will be allowing as a trunk, switch to router port will be trunk, and then we will be assigning the IPs to the PC. And then here we are subnetted. Okay, then we will be using the two usable IPs. We are going to use the /30, which means 255.255.255.252. We are going to use it, that network address. By this, we will get only two valid IPs. We are not going to waste any of the IPs, which is for the WAN network. Here we are going to use in LAN for 10 and 20 and 30, 40. We are going to use the /3024. So let us do the lab from basic for the EIGRP basic lab. Now let us do the basic configuration of this complete architecture, like a interface IP assignment and then enabling VLAN. Okay, all those things before enabling EIGRP in 4 routers. Let us start preparing the configuration. Let us use the router 4331 model, 4 routers, router 0, router 1, router 2, router 3. Let us connect all the 4 routers. Now we are going to do the pre-design. Always we have to be, as a best practice, we should pre-design it before whatever we are going to configure. See here, in this up two ports are used for GA0/0/0. Okay, we can use as a copper or fiber. Here below port is GA0/0/1. This next port is GA0/0/2. Here it is a blank is that we need to insert a SFP. We can use the copper SFP or fiber SFP. Now we are going to use the copper SFP. SFP means the transceiver, which is we can convert as a copper or fiber. Above port already one copper is there. If you want, we can connect a fiber SFP and we can use a fiber port. Okay, below port nothing is connected. These two are same port only. We can use either copper or fiber. In this below port already one copper is there. Here GA0/0/2. So we are going to use a copper. We need in this scenario 3 ports. So we need to use this. Now let us use the copper fiber port here as well. Copper port, sorry. So let me show you what is the copper SFP and fiber SFP. How it will looks, the transceivers. This is what SFP looks. It is a copper SFP. We can say is RJ45 connector. Okay, let us look the fiber SFP also. This is what the fiber SFP looks. Here we can connect the fiber cables. See, that is will be dummy. The modules will be there in router. We can use by using this SFP. We can use as a copper or fiber. Copper means RJ45. Let me show you the front view of ISR 4K routers. Definitely, I'll make a different video for this SFPs, okay, and then modules. Okay, you can go through that by another 1 or 2 days. I'll make one more video for this SFPs and then modules to understand depth. Oh, these are 4321. Okay, our scenario we are using the 4331. Let us search the 4331. Oh, still I'm searching the 4321 only. Okay, let us change 4331. It's the exact model which we are using in the Cisco packet tracer. See here, see by default these two ports, one is enabled with copper. If you don't want to use a copper, we can use a fiber by inserting SFP. But already in this scenario, we are going to use all in copper only. This here below, these two ports are same. It is belongs to GA0/0. Here, this is a different port. This is a different port. Here already copper is there. We cannot change this port as a fiber. Here, this port GA0/0/1, we can use as a copper or fiber based on the SFP, which we are going to use it. In this scenario, we are going to use as all the ports are copper, which is RJ45 model. The term we can say is the T port. Okay, let us connect all the interfaces. Now all the interfaces we have connected. Let's bring the switches also. See, always I prefer, okay, before going to design any network architecture, we need to properly design it in paper, how we are going to assign, okay, which IP we are going to use it. That is the best practice. Okay, now we are putting the two PCs. Now let us make a connectivity between router to switch to PC. Okay. Oh, we are not able to connect. I think I have connected wrong. Okay, I have supposed to connect the below. I have connected to the above. Okay, let us connect here. Okay, connected. GA0/2 is connected. Okay, let us total IPs we are going to use it. Let's make a note in this diagram itself for our easier understanding. While doing it, it will be easy for us to configure it. We have to write it down properly. Then only while configuring it will make our job very easier. Just I have copy pasted. Let us edit a correct IP. Now let us decide a WAN IP. Okay, for Chennai to Mumbai, we'll be using 100.100.100.0/30. Let us fix the IP. Then we'll be using a IP for Mumbai to Delhi is 100.100.100.4/30. Then usable IP will be 100.100.100.5 and 6. Okay, IP has assigned now. Means IP has we have decided which IP we are going to use it. For this we'll use the 200.series 200.200.200.0/30. Then we'll get a two valid IPs 200.200.200.1 and 200.200.200.2. Here we'll use the 200.200.200.4/30. Then we'll get the two usable IPs 200.5 and 200.6. See, this is always best practice. Before doing any configuration, we need to write it down everything properly, which IP is going to assign it. Why? Because it will avoid the confusions. If you're not writing down, okay, if you start assigning directly means we'll get a lot of confusions. Okay, we'll get a doubt which IP we are used here, there, and all. Okay, first, before going to design any architecture, we need to clearly define the IP schemas, which interface we are going to use it. We have to well plan and we have to design it. Okay, let us do the start the configuration. Enable. Okay, before going to give the host names, let us decide the location name also to avoid the confusions. Here is a Chennai, Delhi, Hyderabad, and then Mumbai. Now let us do the proper alignment. See, these alignment are nothing is going to do with the configuration. This is for our understanding, okay, which we are going to make. Config T, router, sorry, interface. Let us configure the host name, CHE Chennai router. IP address. For that, we have to call the interface GI 0/ 0/0. This IP address we are going to assign 100.100.100.1 IP 100.100.100.1 255.255.250.0. Sorry, 252. Oh, sorry, I missed the address itself. Oh, sorry. Address. Okay, we configure /30. See here, we can use the description. Description is for our easier understanding. We are putting on description. This is the description connected to Mumbai. This is for our understanding. In the live scenario, we cannot see this topology like this. We have to make a whatever we are doing in connected interface. We have to make a description. Then only we can able to understand. Here in lab, we are able to see how the routers are connected. All those things. Show in description is a command. It has to work in the live, but this is a simulator. It is not working here. It's a gap in the packet tracer. Okay, if you give in the live scenario, show in description, that command will take. See here, if you give the show running configuration, that is visible. Okay, let us start doing the other interface configurations. Config is GI 0/0/1, which is connected to Hyderabad. IP address 200.200.200.1. 255.255.255.252/30 we are going to use it. Then description connected to. See, this description nothing going to impact our configuration. This is for only for our understanding purpose. Connected to Hyderabad. But always best practice, it should be, we should enable a description, the routers. Now let us do the configuration of the sub interfaces. Encapsulation.1q. Then we are enabling a router on stick. If you want to understand the router on stick, please go through my previous video. It will be clearly briefed on those video with in depth. We have created two sub interfaces for the two VLANs. Now we have enabled a router on stick. Let us show IP into brief. Still this, which is connected to switch, it's showing down. Why? Because we need to unshut it the physical interface GH 0/0/2. No shut. Okay, after doing that, our sub interfaces also came up. Okay, this show in description will work in the live scenario. It's a useful command to understand which interface is connected where. Show IP into brief to show the IP switch is configured in the router. Let us do the configuration of switch. Enable config T host name Chennai switch VLAN 10 named A team VLAN 20 name B team. Okay, let us create a trunk port towards the router which is connected. Interface FA0/1 switch port mode trunk. Okay, trunk port has configured. If A0/213 is the access port, we need to enable into respective VLANs. FA0/2 for VLAN 10, FA0/3 for VLAN 20. Let us save the configuration right mem. This also saving the configuration always is also a kind of best practice. In case of a device got rebooted, then our configuration will be wiped out. Now let us assign IPs to the PCs. Yeah, we have assigned IPs. Let us ping a gateway, which is the router IP 10.10.10.1. Yeah, it's pinging. Let us assign IPs to the VLAN 20 PC as well. Twenty dot 20.20.2. Subnet mask is 255.255.255.0. Let us the ping a gateway IP 20.20.20.1. Yes, it's pinging. Okay, let us do the configuration of the Mumbai router. In Mumbai router and Hyderabad router only, we need to configure two interface, which is connected to Chennai and Delhi. Host name is a Mumbai. G8 0/0/0. IP address 100.100.100.2. Subnet mask is 255.255.255.252. Yeah, we have sent IP address to the interface which is connected to Mumbai to Chennai. Now we are going to assign IP address to the Delhi interface, Mumbai to Delhi interface. 100.100.100.5, 255.255.255.252, which is /30. No shut. Now let us ping from Mumbai to Chennai. Both the interfaces configured. Okay, let us ping from Mumbai to Chennai WAN IP. Yes, it's pinging. 100.100.1 is pinging. Let us save this. After configuring the Delhi side also, Delhi WAN IP also will ping. Now still we are not configured the Delhi side. So we are not ping from Mumbai to Delhi. After configuring, we can try the ping that has a WAN-to-WAN connectivity. Now let us do the Hyderabad configuration. Host name is Hyderabad. Let us configure the interface which is connected to Hyderabad to Chennai, GA0/0/0 IP 200.200.2. Subnet mask is 255.255.255.252. From Hyderabad, we are able to ping the Chennai WAN IP 200.200.1. Let us configure Hyderabad to Delhi as well. IP address 200.200.200.5. Separate mask is /30. It's configured. Save the configuration in the Hyderabad router as well. Let us verify the IP. Show IP into brief. Yeah, it's the done. Only J0/0/1 is showing as a down protocol. Why? Because still we have not configured Delhi yet. Once we configure Delhi, it will come up. Let us do the configuration of the Delhi. Enable config T, hostname, Delhi router, interface GI0/0/0, which is connected to Mumbai, IP address 100.100.100.6/30, GI0/0/1 we need to configure. No. GI0/0/1. IP address 200.200.200.6, 255.255.255.252, which is /30. No shut. Now from Delhi towards Hyderabad and towards Mumbai, interface is configured. Let us ping Hyderabad and Mumbai from Delhi. It is pinging. This is the way we need to verify the WAN IPs, our next top IPs, whether it is up or down. If it is down, okay, usually we'll be raising a case with the service providers. Okay, let us enable the router and stick towards the LAN interface. Encapsulation .1q 40. IP address 40.40.40.1, which is a gateway for VLAN 40. 255.255.250, and then we have enabled the let us enable the physical interface of GA0/0/2. Yeah, it's enabled. Okay, now everything is configured in the Delhi router also. Let us do the configuration in the Delhi switch and Delhi PC as well. Enable config T, hostname, Delhi, switch SWT, FA0/1, switch port mode trunk, that is trunk. Okay, and then interface, before that we need to enable a two VLANs in this switch as well. VLAN 30 and VLAN 40. Name as a C team and a D team. Exit. Let us enable the access port here. FA0/2 and FA0/3 is the access port, switchboard mode access, switchboard access VLAN 30 and 40. Let us enable here. Switch 4 interface trunk. Let us verify the trunk code. Yes, FA0/1. It's correct. Show VLAN. Okay, the VLAN 30 and 40. Okay, it's correctly mapped with the correct interface only. Everything looks fine. Let us save the configuration. Let us start assigning IPs to the PC. Now, network devices, core devices work is completed. Now, let us assign IP to the 30.30.2 and 30.40.40.2. 2, 255.255.255.0, 30.30.30.1 is a gateway. Let us ping a gateway. Ping 30.30.30.1. Yes, it's pinging. Gateway is pinging. Now configure the 40.40.2 PC as well. Still, let us configure 40.40.40.2. Subnet mask is 255.255.255.0. 40.40.40.1. Yes, it's configured. Let us ping the gateway. Yes, it's pinging. Now we have completed the basic configuration, LAN, WAN, everything. Okay, now the 4 locations, we need to configure a EIGRP between these 4 routers. Post that, everything will work out. Now we have configured done the basic configuration before enabling EIGRP. Now let us do the configuration of EIGRP. Let's start with the Chennai router. This is similar like a RIP, but small changes will be there, like autonomous system numbers, those things are done. Router EIGRP. Give the question mark. Okay, it will show as an autonomous number we need to give. It should be anything. Okay, but all the routers should be the same autonomous number. Then only the neighborship will get formed. Let us give as an autonomous system number 1. And then network. We need to give as a network. Network here we need to give as a 4 network, 100, and then 200, and then 10, 20. Okay, here we cannot give the subnet mask. Okay, here should use the wildcard mask, is just opposite to the subnet mask. But if you give the subnet mask also, it will convert to the wildcard mask by router itself. We no need to bother about that wildcard mask much. But let me brief about that wildcard mask. What is that? Wildcard mask is just opposite to the subnet mask. Let me show you that wildcard mask. Before that, let us configure the 200.200.200.200. Let us give it the subnet mask. If you give the subnet mask also, it will automatically convert a wildcard mask by router itself. Network 10.10.10.0, 255.255.255.0. Okay, we have configured now 3 networks. The 20 will do it later. Let me show you the show run. Whatever we given, it will be in different opposite format. Now see here, it is converted as a wildcard mask by router itself. If we give the subnet mask also, under the EIGRP, it will convert as a wildcard mask by automatically by router. How do find out the wildcard mask? Let us do this calculation. 255.255.255.255. Okay, let us put a subnet mask below 255.255.255.0, which is subnet mask of /34. Now, if you minus this, what is the value comes? That is a wildcard mask for /24. Wildcard mask. A simple calculation. Okay, we need to actual subnet mask. We need to subtract with the 255.255.255.255. If you do that, we will get a wildcard mask value. It's just opposite to the subnet mask. Now we are finding a wildcard mask for /30, which is a 0.0.0.3. This is a simple calculation. If you don't know this calculation also, no need to worry. If you give the subnet mask in the router, it will automatically convert as a wildcard mask. Just for your understanding, I am showing here how to calculate this wildcard mask. This is opposite to the subnet mask. Okay, this is a subnet mask for /25. Wildcard mask is clear, right? Now let us focus on the configuring Mumbai router as well. Show IP EIGRP neighbor. Still neighbor is not formed. Why? Because opposite routers are not yet configured. Post configuring, these neighbors will get displayed. Let us configure the Mumbai router. Config T, EIGRP router, EIGRP1, and the network is here we need to configure the two networks 100.100.100.0 and 100.100.100.4. Now adjacency is formed. Okay, since already we configured Chennai router, Chennai to Mumbai, EIGRP got formed. Now Mumbai, we have configured the EIGRP. Show IP EIGRP neighbor. Let us give that command. Yes, EIGRP is established towards Mumbai to Chennai. Let us configure the Delhi. Now Delhi, we are advertising the four networks 100.100.4/30 and then 200.200.4/30 and 30 network and 40 network. Now the neighbor is established between Delhi to Mumbai. Okay, now neighbor is established from Delhi to Mumbai. Okay, already we have configured Delhi to Hyderabad also. Still Hyderabad router is not completed. So now one path we have enabled Chennai to Mumbai, Mumbai to Delhi. Like that we enabled. Let us check the routing table. Show IP route. From Chennai, we are able to see the Delhi two subnets 30 and 40. Show IP EIGRP. Okay, show IP route EIGRP. We are learning the 20 and 30 via Mumbai. We are able to see that route. Let us do the ping from Chennai to Delhi. Yes, it's pinging. Yes, it's pinging. The gateway, the trace also, it's going to the gateway 10.10.1, and then from gateway to it is going to the Mumbai. From Mumbai to it is going to Delhi, and then it is reaching the destination. Now let us do the configuration in Hyderabad as well. Config T, network 200.200.200.0/30. Here I am giving the wildcard mask 0.0.0.3, and then 200.200.200.4. The wildcard mask is 0.0.0.3. We can give subnet mask also, no problem. Show IP EIGRP neighbor. Okay, both the neighbors came up from Hyderabad also. Hyderabad to Chennai, Hyderabad to Delhi. Now this path also is ready. Now both the paths are ready via Mumbai also ready, via Hyderabad also ready towards Chennai to Delhi. Show IP route EIGRP. You could able to see both the paths are available. You see here, both the paths are available via Chennai and via Mumbai and via Hyderabad for the destination. Why? Because both are same feasible distance. We show IP-EIGRP topology figure. Okay, both are same feasible distance and advertised distance. So both the paths are showing. Since here we are using the default values, we are not customized anything with the path. So it is taking a default value. Both the routers, hop counts, everything remains same. So it is taking as the same feasible distance. So it's showing a two path as a successor. Okay, in the upcoming videos, we'll see the how do the policy path primary, secondary. Here, what will happen? Both the paths are equal distance, so load balancing will happen. Okay, some traffic will go via Mumbai, some traffic will go via Hyderabad. Some packets, I can say. So now let us do the trace route. How it is going? Let's see. Here it is was completely going via Mumbai, right? Now it is going via Chennai, Hyderabad. Now here partially is going via Chennai and coming via Hyderabad. Mumbai and coming via Hyderabad. Same way here, going via Mumbai, coming via Hyderabad. Now this path is completely going via Hyderabad and coming via Hyderabad. Now load balancing is happening between Mumbai and Hyderabad from Chennai to Delhi. It is using both the paths. Sometimes it go via Mumbai, sometimes it go via Hyderabad. This is a load balancing in the EIGRP. In upcoming videos, we'll see how this Mumbai as a primary, how we will make a Hyderabad as a secondary. Those things and all we will discuss in brief post you understanding EIGRP basic configuration. Those videos I will be uploading in upcoming videos. Now completely EIGRP we have configured. Let us do the ping from here to there. Ping 10.10.10.1. Oh, sorry. This PC is pinging from there. From 30.30.2 it's pinging. Let us do the 20.20.20.2 also. From 40, let us ping the 10 and 20. IP confirm what is IP 40, right? 40, yeah. Ping 10.10.10.2. It's pinging. Let us ping 20.20.20.2. No, it's not pinging. It is dropping at a gateway itself. Let us check the configuration in the Chennai router and 20 PC. Configuration is fine here. Let us check it in the Chennai router. Let us check the Delhi router whether we are receiving a route for 20 or not. Show IP route, we are not receiving any route for the 20. Then some advertisement problem in Chennai. Let us check it out. Show run will give what is we advertise in the EIGRP. Let us relook whether we advertise 20 or not. We'll check it out. Show run. Oh, 20 is missed. That's why 20 is not advertised from here. Config T, router EIGRP1. Network 20.20.20.0. Wildcard mask we can give 0.0.25 or subnet mask is 255.255.255.0. Sure run. Okay, we have advertised here. Let us see in Delhi whether we are receiving that route or not. Before that, we can ping also. It will start ping. We can go to the Delhi router and verify show IP route whether we are receiving routes. So obviously we should receive the route. That's why we are able to ping. Okay, this is the configuration which is required for the Chennai site. These are 4 lines, and then these are configuration required for the Mumbai router. EIGRP perspective configuration only I'm showing here. The rest of the configuration, the interface configuration, which we need to do it. And then this is the configuration for Hyderabad. And then this is the configuration for Delhi, which we need to do it. So these are the configuration which we need to do it in all the routers for the EIGRP expert. This is a calculation for the wildcard mask which we discussed. You just understand that this is a wildcard mask configuration. This is the wildcard mask calculation which we need to do it. Now these are the basic configuration. Okay, we need to do EIGRP basic configuration. Please practice this with the lab. Okay, if you have any doubts, please reach me out over the command box. Okay, I will be definitely will address your queries. Hope this video makes you clear about the EIGRP basic configuration. Please do the lab and enjoy it in EIGRP. These are the configuration which we did it for the EIGRP perspective. If you want, you can have a look. Thanks for watching NetTalks Tamil. Please like it, share it, subscribe it. If you have any doubts, please drop your doubts in the comment box. It will be addressed in upcoming videos.